Welcome back. We want to talk about storage, energy storage. And with us today, we have a very heavy-duty speaker, Dr. Huashan Wang. He is the founder and chief technical officer of Omnivoltaics, and his passion, he has such passion for ensuring that energy gets to the ground level. He's talking to us about charting the path to 100% clean energy power grid through smart energy storage solutions. Dr. Huashan is the founder of Omnivoltaics. He has worked in very many places, including GE and Emerson Electric. He's an entrepreneur as well. Technical people never make great entrepreneurs. That's the myth. Today we are here to bust that myth. You can be a techie and you can be a great entrepreneur at the same time. His work has ranged from product design, marketing, quality in terms of Six Sigma, automation, robotics, engineering, and he's very passionate about renewable energy. His interest at the moment is off-grid electricity generation and use with a strong focus on battery. You can see this passion for renewable energy, which is the focus of our theme for these 2 days, is spanning geographies. It's spanning technology. We have a global speaker in the house coming to us all the way from Palo Alto, where he lives with his wife and his 2 daughters. He has a PhD degree from Imperial College, University of London, UK, and a BSc from SCIAN. And so we are so ready to listen to you, Dr. Huashan Wang. Please take it away and talk to us about energy storage. Over to you.
Thank you very much. I hope you can hear me. All right, so my talk is about energy storage, but specifically in the context of the smart energy. So we don't have a lot of time to go into very deep technical details. Something I'm prepared to do with you, hopefully in the right venue. But instead, I thought I would share with you my perspective as an entrepreneur, the lessons learned, the path we're taking, and the passion we're sharing with the world. So with that, I will jump right into it. By the way, can you see my screen? I'm not so sure you can see everything. Okay.
Yes, we can.
Yes.
Great. So what are we talking about? When we talk about storage, smart grid, things like that, there are always many, many definitions and many people are talking about different things. So I thought we take some pause and just agree on what are we talking about. And also like to share with you what my views are regarding the stakeholders and who is the most critical stakeholder in the whole process, which is the end user. And also I want to touch upon some technical advances, some of the things we're doing as a company. Of course, we are tackling a small part of this great adventure, which is a smart grid. So whenever you talk about smart grid, you hear a lot of different views. So we're not here to talk about what's right, what's wrong, but only to point out that there are different are based on geographic focus, some are based on policies, and there are entrepreneurs, business people like myself, but then there's also the end user. I guess it's important that while all the what truly matters is the end user. I think that's one of the things we'll also always learn, that end user at the end of the day should be the voice we always listen to. Let's talk about what are commonly agreed upon as a smart electric grid. Again, these are the standard definitions you can find on the internet. There are a lot of big words, a lot of big paragraphs describing what smart grid is and what is not. But fundamentally, I think we can all agree that smart grid is just electrical grid with internet, right? So when internet comes into play with energy, all kind of possibilities open up. And it is particularly true in developing countries where so many different applications, so many different opportunities present themselves. It's like the early days of internet when people talk about different applications, but nobody could tell you the scope of those possibilities. It's the ingenuity, it's the creativity of an entrepreneur and frankly, the end users that will tell us smart grid ultimately would be. But I do want to share one chart. This is a chart you will see on Wikipedia. I thought it was interesting to share with you again. This shows you the kind of grand evolution from what is referred to as traditional architecture to what is now termed as a smart grid. As you can see, the few things are quite obvious. We're moving away from fossil fuel into renewable energy. We're moving away from long-distance centralized transmission into more decentralized hub-spark models for energy distribution. And we're talking about localized, safer distribution. And most importantly, the consumer plays a much more important role because now the energy flows both ways. A household can also be a generator. So this great evolution is a powerful enabler that allow individuals to participate. I am not going to go into details to talk about some of the attributes of smart grid, but suffice is to say that smart grid fundamentally allows a lot of different optimizations. It allows your assets to be utilized more efficiently. Basically, when internet is combined with energy, the possibilities are endless. I do want to talk about a term. We use the term IoT. So it is the Internet of Electrical Things. So if anything you take away from my talk today, what is smart grid is interconnectivity plus energy storage, right? Because energy storage is such a pivotal element of all smart grid. It is energy storage that allows individuals to take their own energy consumption destiny. It also allows much more equitable equitable arbitrage between suppliers and consumers. I think it's truly where the consumer now has much more power regarding how and when they consume power. I also want to share one screen just very quickly, again, from a stakeholder. We'll talk about different stakeholders from policymakers to investors to supply chain and practitioners. But let's not forget the most important stakeholder is the end user. And smart grid at the core allows the end user to have a lot more individual choices. Okay, so now let me jump into what we do as a company from an entrepreneur's perspective. So if someone asks me, what are the things important in a smart grid or, internet connected grid, I'd say the most important thing is energy storage, because it is energy storage that changed everything. Nowadays, energy generation from solar to from wind is a fairly well-established technology. But energy storage, however, remains to be a challenge. And this is a challenge we're facing today. And by overcoming some of the issues with energy storage, this is the final barrier to a truly equitable and accessible, universally accessible energy source. All right, so let me go through some of the things we do as a company. I threw in a lot of terminology. Again, the idea is not to confuse everyone, but I want to do some of them because they represent such important breakthroughs from our point of view as a technologist. I'm not going to go through every one of them. Let me just pick up a few things that may be interesting. One of them is called ARM. So ARM represents a asset relationship management. So this is where you can actually take your energy generating storage devices into investable assets. One example of that is in the off-grid pay-as-you-go, for example. That's one example where an electrical device becomes an asset. I want to point out is one of the technologies we're working on very much these days is the EME. So most people are familiar with electrical mobility. This is where cars and electrical motorcycles come into being. We of course do that, but we look beyond e-mobility. We also look at mobile electric, because mobile electric essentially is the flip side of electrical mobility. Electrical motorcycle or your electrical cars can be also used as part of your energy storage solution. When these two concepts begin to play together, we'll truly find very interesting and innovative ideas. I would also talk about avatar. This is one of the things we talk about smart grid. The question always becomes, how do you access and query your devices? How do you understand? How do you find out information, right? So avatar technology is one where we essentially create a digital twin of your physical assets, whereby you will be able to access, query the status of the device via internet technologies such as APIs and web services, things like that. So avatar is going to be one of the key technologies that will level the information access. Another thing I'd like to talk about is this power cascade model. This is a model we have been pioneering and promote for many years. So the idea is very simple. The idea is that energy consumption, energy adoption comes in stages. And the question is, when can you move from one ladder to the next one? This so-called energy ladder is critical and fairly important in the pathway evolution into higher and better energy consumption. So many of you are familiar with small household off-grid power solutions we are part of. We produce things like a small solar lantern and home system, and so forth. The question is, when you have those devices, how do you move up? How do you make sure the kind of devices you put into your house will remain to be useful tomorrow? How can you connect them? How do you truly exhaust the lifetime value of those investments? So our proposal is to use a so-called power cascade model, where devices are interconnectable and energy flows from higher up downwards. So for example, we already are familiar with 5 volts, small USB portable electronics. We're also familiar with the small home systems at 12 volt voltage. The next up is the larger home systems. Maybe we can go into a 48 to 70 volt DC system where you can put larger televisions, fridges, bicycles, things of that nature. Then ultimately, you will be able to connect to the AC bus where you can charge your local batteries. So the idea of a cascade model is no asset is wasted. And as long as you have a data connectivity, as long as various players, various components of the system can interoperate, you do not waste money. I think it's a key thing for people to understand. Even you invest in today's more off-grid systems, via power cascade model, you can fully maintain and utilize the assets you have invested in. As an entrepreneur, as a company leader, we choose to focus on certain aspects of energy applications. In our case, we focus on the human needs. So these are the things we consider most important. These are water, from extraction, pumping, treatment, to the movement and the monitoring. This can be used for farm and communities. We'll look at the agriculture. Again, we'll talk about irrigation and food preservation is such an important aspect of energy application, because by providing some fairly inexpensive cooling solutions, refrigeration, for example, you can really keep a much larger portion of your post-use. We are very passionate about, promoting good food preservation technologies through refrigeration. We'll talk about mobility. Mobility is obviously important. So we are familiar with some motorcycles, for example, but so are things like electric small boats. We actually have a program in Lake Victoria where we're experimenting with electrical propulsion for fishing. We're also talking about ice making to keep your fish catch fresh. And of course, we're looking also at battery swapping, whereby all these mobility devices can share a swappable battery. We're looking into installing battery swapping stations, whereby boats, riders, things like that, they can share the batteries. I think health is another critical aspect for power to be playing a very important role. We implemented clinics power and also things like vaccination, refrigeration and transport, and assisted living. I'm very optimistic about smart grid future, especially in Africa and some of the Pacific Island countries, because this is exactly the right place and right time for this, right? So, we have witnessed these great advances in solar in the last 20 years and the battery storage in the last 10 years, but combining those technologies with internet, things become very, very interesting. And we think it is very promising, especially for Africa. We actually have a team in Nairobi. We have smart young people who are trained in technology, who can install, repair, in some cases, assembly. They can actually write codes and applications. They can provide services. I think this younger generation is an entrepreneur and modern technical backgrounds will provide to be extremely, innovative blood for this new industry. I'm going to just share some lessons learned. Again, there are many lessons learned, but these are the few things I think will be particularly worth sharing. Learn is quality is everything, especially when you're talking about energy, equipment, products you will use for years to come. Quality is important, but quality is hard to achieve. And the cost of poor quality is very costly. We learned that in hard way. So that's why when we deploy products in developing regions, think of it is almost like a space mission. We're trying to send, if you're trying to send something to the Mars, you better make sure it works. Otherwise there's very little chance for post-installation repairs. This is just very difficult to do. So we believe quality is the number one factor to ensure a life cycle value. Information provenance, why that? Once you get into the Internet of Things, very quickly you will find out that to be able to track your devices, to be able to rely on the information your devices emit, you have to be able to trust the origin of information. So information provenance is a key concept everyone must be aware of. You got to be able to trace information all the way back to components. You cannot trust simply someone publishing a message on the internet. We cannot trust on people, neither can we trust on devices to be always truthful. The last thing I want to say is not a complaint, but I want to mention this anyway. That is, financing for distributed is always hard. We have been working in this field for the last 20 years. I think technology has been advancing rapidly in the last years, but funding mechanism, in my view, is outdated. Many of the bankers, financiers we talk to still use outdated valuation methodology, so they don't really understand the true value sometimes. I hope this will be an area technologists bankers truly come to the same page and work together. I just want to leave a last thing to share with the team. You know, we understand this is a technical field. There are a lot of discussions for quality control policies, things of that. I would propose a few proactive ideas. This is especially for those in the room, maybe from the policy. I would strongly propose that we cut down. Well, let's talk about transparency. Let's have more transparency, but less standards. Because standards are very hard, and what is the right level? But transparency allows people to see and judge. Let's have more accountability, and let's have more clear rules and not vague values. But most importantly, let's have real numbers. Let's have a few judgments. So these are things I want to share, and I believe passionately in. So with that, I will just conclude my talk. Hopefully that was useful to you, and I look forward to continually talking with you. Let's stay in touch. And my name is Huashan Wang. I work for Omnivoltaics, and you can contact information on this page. With that, I'll stop. Maybe there's some questions I would answer. Otherwise, hand back to you, the host. Thank you.
Thank you very much, Dr. Huashan. Very interesting. It was very useful to us. You're saying you hope. Don't hope. I am here to confirm that your conversation with us this morning has been very useful. You've told us that no asset is wasted. We are taking that. Your talk has tied into what we've been discussing this morning, a lot on food security. You're talking about ice making and refrigeration. You're talking about harnessing that. And your last slide on what we can do more of and what we can do less of is really important to us at this time. I'll open the floor. We have a few minutes for questions. Is there any question, comment that anyone would want to make? Online team, you can put your question, comment in the chat, and we can pick it up from there. So we can pass around the mic. Anybody, you can raise your hand if you have a question or comment. We have a question right there on that mid-table.
Thank you very much. My name is Benson. I'm from Renewable World, and I'm an electrical engineer, so I really get to understand what Wang is talking about. So my question to him is, he has really talked of something which has really touched my nerves about power cascade model. Is that power cascade model something still in research, or is it work in progress? Because that big element of no waste of any asset is very critical in renewable energy or being efficient. So yeah, that is my question, because outside here we have a couple or a number of technologies around energy efficiency. They fail sometimes. The core is always storage. I know that. So again, that one goes down to the environment. So if we have anything like, I love that power cascading model, it can easily take up those wastes. The environment will be safe. The assets will be in place to be used up to the end of their life. And I think that will be very good for energy profession and the country and economics in the world. Thank you.
Thank you very much for that question. Let me confirm that power cascade as a concept have existed for years, but we actually have installations in various places. It's not a complete, you have a complete cascade of its all elements, but to create to AC/DC combined systems, to 48-volt systems, all the way down to lanterns that is operating in field today. One of the things I really want to emphasize, I'm sure electrical engineers appreciate that in off-field space, we have these LED lights. These lights will last for years, 10 years, 20 years. Why waste them? They should continue to work. And also the very, very, very efficient. Your DC bridge, all the things continue to work. It's the interconnectivity that's the key. Again, this is part of the smart grid thing. Once you can make them connect, then all the assets will continue to be useful. I just want one thing, in addition to Cascade, the mobile to electric to mobile concept, basically your vehicle is your storage, your vehicle contains storage. This concept will come into play in a big way. I think Kenya will probably be the first country to see real examples of that.
Yes, thank you very much for that very comprehensive answer. You've talked about the interconnectivity of things. And I think that's where we all need to ask ourselves, because everything, absolutely everything is interconnected. So where do these interconnectivities interlock with each other? How can we harness value at each point from end to end? What can we save? What can we ensure is not wasted? Zero wastage, no asset is wasted. And so we've picked up on that. You talked about water, agriculture, mobility, and health. And when we look at what basic things we must run with, these are them. And so we thank you very much, Dr. Huashan. A round of applause for him. Online emojis for the online team. And I think there's some questions from there we can take. Is there one or two questions from online? Over to you.
Yes, we do have a question from Tadeo from Uganda. And the question is, on addition to the grid power under the Cascade model, is there any progress about wireless transmission of electricity?
The answer is no. We don't look into wireless transmission, wireless charging in this context. I think when we talk about the Cascade, we're really talking about arbitrage between various players on the grid. So we're talking about household to household transmission, but via Cascade, some person in Nairobi can share her energy with someone in Kisumu. So that the idea is not about wireless transmission, but a virtual transmission via common shared information technology. So energy electrons can fly anywhere. It is information that enables this equitable sharing. But no, wireless transmission is not part of this discussion.
Let's have a final round of applause. Thank you so much for your time. Thank you for investing in knowledge transfer and capacity building. We honor you for that. And happy Mashujaa Day. You are a hero. We are celebrating heroes in Kenya today, and you are one of them. Thank you.
Thank you. Thank you for having me. Bye.
All right.